So this set of notes is just looking at slope fields and also solving differential equations again. So practicing solving some differential equations. So we've given these separable differential equations. So to solve these again, we're going to separate the x with the x, the dx, and the y with the dy. So writing this out, I get dy over y is equal to 2x dx. I can say that the sum of those parts and the sum of those parts are equivalent. So I can solve this differential equation by anti-differentiating this. Okay, so it's implied that we should solve for y. So here when I solve for y, I get x squared plus c. Okay, so this is good enough. However, we could also say that e to the c is a coefficient on this exponential function. So we can say this, we can say that some constant times e to the power x squared is also equivalent to that. For this one here, again, we can separate out the variables. The 6 can go with the x or the y. I'm just going to leave it with the x. So I get 6x dx. Separate my variables. Integrate both sides. I get y to negative 2 divided by negative 2. This is going to end up being, what is it? It's going to be 3x squared plus c. What's implied again is we should solve for y. Okay, so I'm going to rearrange this. So this ends up being y squared on this side, 1 over negative 2 times 3x squared plus c over on this side. Okay, solving for y. Really, I actually should just leave it like that because we can't really solve for y here. Because when we solve for y, we get the plus minus. So I'm just going to leave it in that form. So for these ones, it's the same thing. We need to separate and integrate, but we're given initial conditions so we can actually solve for c. So here, to solve, I need to first of all be able to factor and be able to separate my x and y by times and divide. So once I've factored it, I can split up my y with my x, integrate both sides. Log of 1 plus y equals x squared over 2 plus c. So now we can solve for c. I can plug in here and solve for c, you can isolate the y and solve for c. It might be just easier to plug in the x and y now. So log 1 plus 0 is equal to 0 squared over 2 plus c. That's 0, c equals 0. So then my solution is log 1 plus y equals x squared over 2 plus 0. Solving for y, I get y equals e to the x squared over 2, and then that plus 1 becomes a minus 1 on this side. So same thing here, we split the variables. So I end up with cos squared y in the denominator here. E to the x dx, integrate. This ends up being e to the x plus c. This is same as secant squared y dy, so this is going to integrate to tan y. And that equals e to the x plus c. Plugging in the coordinate, I get tan of pi over 4 is equal to e to the 0 plus c. That's equal to 1, 1 plus c, c is 0. So my equation looks like this. Tan y equals e to the x. Okay, I can solve for y. I can say that y is equal to the arctan of e to the x. Okay, and that's the solution. That's the specific solution that passes through that coordinate.